Matrix multiplication is essentially the calculation engine that drives artificial intelligence. While tools like vectors and matrices might just look like simple grids of numbers to us, this math is the actual mechanism an AI uses to process information. Let's look at how this flows. The system takes your input data, for example your personal movie preferences, and combines it with its own internal knowledge, which we often call weights. By blending these two elements together, the AI can produce a highly specific result, like a great movie recommendation. Because this is the core of how AI thinks, this process is the most frequent mathematical operation performed by computers in the modern world. To understand how this math actually works without needing any complex technical background, let's look at a simple analogy: placing an order at a coffee shop. Imagine we have two sets of information which we'll represent as vectors. A vector is simply an organized list of numbers. Vector A represents your order, containing 3 espressos and 2 muffins. Next to it, vector B represents the prices for those items. An espresso costs $4 and a muffin costs $3. To calculate your total cost, you naturally perform a specific sequence. You multiply the corresponding items and then add them together, known mathematically as a dot product. Let's break down exactly how you do this in your head. First, you take the 3 espressos and multiply them by their $4 price, which gives us $12 for the espresso total. Next, you take the 2 muffins and multiply them by their $3 price, which results in $6 for the muffin total. Finally, you simply add that $12 and $6 together to get a grand total of $18. Now, what is matrix multiplication? Matrix multiplication is simply performing this exact same dot product move many times over for different sets of data. It's exactly like calculating the totals for many different customer orders all at once. So your main takeaway here is that a dot product takes two lists and turns them into one single total value. Next, we'll see exactly how we apply this identical logic of matching lists and combining totals directly to AI inputs and weights, like interpreting the brightness of pixels in an image.
In the context of artificial intelligence, we apply this exact logic to two main components: our inputs and our weights. To give you a real-world example, an input could be something like the brightness of a specific pixel in an image, while a weight represents how important that specific pixel is for identifying what the image actually shows. The fundamental building block to combine these is called the dot product. To do a dot product, you need two lists of the exact same length. Looking at the formal mathematical definition here, you simply multiply the corresponding neighbors. You take the first item in vector A and multiply it by the first item in vector B. Then you do the same for the second items and so on, all the way to the last items in your lists. Notice the plus signs between the pairs? You add all those individual products together to get one single number sum. Now, matrix multiplication is just the repeated application of that simple dot product. But there is a golden rule for this to actually work. To multiply two matrices together, the number of columns in the first matrix must exactly match the number of rows in the second matrix. If these numbers match, it's like puzzle pieces that fit perfectly together. If they don't match, the puzzle pieces clash, and the multiplication is impossible. To easily visualize this process, imagine using what we call the hands method. Imagine using both your hands to track the numbers. Your left hand moves horizontally across a row of the first matrix. At the exact same time, your right hand moves vertically down a column of the second matrix. Every time your fingers land on a pair of numbers, you multiply them and keep a running total of the sum in your head. Once you reach the end of that row and column, that final sum becomes just one single entry in your new resulting matrix. So always remember, you slide across the rows of the first matrix and down the columns of the second matrix to find your perfect pairs. This exact sliding and multiplying action happens constantly behind the scenes in real life. For instance, in e-commerce platforms like Amazon, This mathematical engine fires every time you browse to calculate your perfect product match score.
We just saw how the dot product multiplies lists of numbers together. Now let's explore how matrix multiplication is actually used in the real world to solve huge problems. In e-commerce platforms like Amazon, this math is happening every time you browse. Look at this e-commerce recommendation system. We start with Matrix 1, which tracks users and their interests in broad categories like electronics, fashion, or books. Then we have Matrix 2, which scores specific products like a smartwatch or a novel against those exact same categories. By multiplying these matrices together, the computer calculates a match score for every single product against every user. So if your row shows a high interest in gadgets, the math automatically connects that to the smartwatch column, giving you a highly personalized recommendation. Netflix uses a powerful variation of this called Matrix Factorization. Imagine a massive user movie grid where every row is a person and every column is a movie. Most of this grid is completely empty or sparse because nobody has watched everything on the platform. By using matrix math, the AI looks at the ratings you did give, compares them to similar users, and literally predicts and fills in the blanks for movies you haven't seen. This calculated grid is exactly how they know what content to suggest for you next. To actually perform these calculations in the real world, developers use Python and a library called NumPy. Let's look at this NumPy matrix multiplication code. Using Python, we define our first grid using np.array for our store prices, which creates this 2 by 2 prices matrix in memory. Next, we define our orders for our customers, creating this second matrix right below it. The magic happens with the np dot function. It performs the entire multiply then add logic across the rows of prices and the columns of orders, instantly outputting this final calculated matrix which shows the total bill for every customer at every store. To solidify your understanding, let's run through these practice questions. First, if vector A is 1, 2 and vector B is 3, 4, what is the dot product? We multiply the neighbors 1 by 3 and 2 by 4 and add them together, which gives us exactly 11. Second, can you multiply a 2 by 3 matrix by another 2 by 3 matrix? Remember the golden rule. The columns of the first matrix, which is 3, must equal the rows of the second, which is 2. Since 3 does not equal 2, this operation is impossible. Third, in a dot product, do you end up with a list or a single number? As we just saw, the answer is always a single number. Finally, try this practice problem on your own later. You can create a matrix of hours worked and multiply it by a matrix of hourly wages to easily compute the total payroll for multiple employees at once. Matrix multiplication is not just abstract math. It is the fundamental engine that summarizes complex grids of data into actionable insights across all modern